Hi, so today we are going to be working on compound events for probability. So why am I not typing here? I can find the probability of compound events. There are several different types of compound events for probability. So we're going to talk through them all, and then we're going to spend the next week or so practicing the different types. But these will be all of our notes. So if it seems like I'm teaching you a lot, I am. You're going to continue to use these notes as we continue to practice throughout the next couple weeks. So compound events. It is possible to find the probability of more than one event or more than one thing occurring. A blank consists of more than one event. So, hey, there we go. Compound event. What are some examples of compound events that you can think of? So thinking about compound events, it's like going to be like spinning a spinner and rolling a dice. Or maybe it's even drawing 2 cards out of a deck of cards instead of just one. Things like that would be considered compound events. So then when you think about compound events, there's 2 types. So there's the independent events and there's the dependent events. Independent events have nothing to do with each other. It's like spinning the spinner and then flipping the coin. It doesn't matter what happens on the spinner. You could get either thing on the coin. So independent events do not depend on each other. One doesn't affect the other. So examples of this would be a spinner and a coin. Dependent events, that would be things that do depend. So if I want to know what the probability of drawing an ace out of a deck of cards, and then that card is no longer in the deck, so now instead of 52 cards, I only have 51. So what's the probability of drawing another ace? It completely changes the probability now that you have less cards in the deck. So dependent events do depend on each other. And one does affect the outcome of the other. And then, so what are some examples of that? Drawing from a deck of cards, or if I'm asking for volunteers in the class, the probability that I would choose you to begin with would be like 1 out of, right now, 1 out of 12. And you're already a volunteer, so now I'd only have 11 people left in the class. And so now the probability of me drawing the next person would be 1 out of 11. And so it's being affected. So picking volunteers, any of that could work. So the probability of independent events. So really for both of these, what you're going to do is you're going to find the probability of each thing happening and then multiply them together. So if we think of, I'm going to do 2 coins since we don't have a spinner picture here. So it's like the probability of 2 heads. That would be the probability of the first head would be 1/2. The probability of flipping the coin again and getting another head would be 1/2. So you would do 1/2 times 1/2. So you think about it and you multiply the numerator first. So 1 times 1 is 1, and then 2 times 2 is 4. That looks kind of run together, so I'm going to put some spaces in there. Oh, hey, look, that really helped anyway. There we go. So then that kind of cleans it up a little and separate it. So the probability of getting heads the first time is 1/2. Think of it completely separate. So the second time, what's the probability of getting heads? 1/2. So to find the probability of flipping 2 heads in a row, you would multiply those 2 together to get 1/4. The probability of dependent events is going to be the same thing. So what if I did 2, so the probability of 2 aces? Well, the probability that you would flip over an ace the first time, there's 4 aces in a deck of cards. So if you don't know how like a standard deck of cards is built, there are 4 aces, 4 2s, 4 3s, fours, fives, six, sevens, eights, and there's four different suits. There's clubs, diamonds, spades, and hearts. And so each of those suits have an ace. Each of those suits have a 2 and a 3, all the way up to 10. And then they each have a jack, they each have a queen, and they each have a king. So then there's 4 kings, heart, spade, diamonds, clubs, 4 queens, yada, yada, yada. So altogether, that's 52 cards, and there's 4 aces. So I've drawn that ace, and here we should add this on here without replacing. So I draw that ace, so it's no longer there. So then now when I look at my deck of cards, I only have 3 aces left. And then altogether, I only have 51 cards left. So there were 4 aces. I drew you always assume you get what you want. So you drew one of them. So now there's only 3 left. But then in the whole scheme of things, that card's gone. So instead of 52 total, there's 51. So then to find the total, you're going to multiply. So 4 times 3, that one I can do. But 52 times 51, I cannot do that in my head this quickly. So 51 times 52 is 2,652. And then you can simplify that as a fraction, or you can make it into a percent. So we're going to simplify it as a fraction first. So looking quickly at these, I can see that they're both even. So I can divide them both by 2. So 6 divide by, let's see, what is that? 1, 3, 2, I don't know. So let's just put it in there. 2652 divided by 2 is 1326. Okay, those are still both even, and so must means I could have taken something bigger out than 2 to begin with. So now dividing them both by 2, 6 divided by 2 is 3. 1326 divided by 2 is 663. So I don't know if so they're not both even now, so you would think you can't divide them by 2. But when I'm looking at this, I can divide both of these by 3. The rule for 3 is that you add up all of the numbers, and if that's divisible by 3, the whole thing is. So 6 plus 6 is 12, plus 3 is 15. So that means you could divide that by 3, and you would get 221. Now that you got it down to 1, it's not going to go any further than that. And so what that means is way up here, if I would have taken just a little more time to think about it, I could have seen that 2,652 is divided by 12, and I could have gone straight from here to here, but that's okay. So what I want you to do is you are going to go to page 17, and I want you to try to separate which of these are independent events and which are dependent events. And then try page 17 on your own. And then there'll be another video to explain it after you've tried it. Thanks.